So next examples are some fractional expressions involving exponential functions. So eventually we want to use the graph of exponential functions. Whenever your base is greater than 1, the graph will increase like that. So the limit of this function will be infinity as x tends to infinity. On the other hand, if your base is less than 1, the graph will decrease like that, and the limit will be 0 as x tends to infinity. So in the first example, we have copy of e to the x. So as you see, e to the x will be huge number when your x is getting larger and larger. So leading term, in that sense, is e to the x. So to find the limit rigorously, you want to divide everything by the leading term. So basically, when you divide everything by e to the x, we will have 7 over e to the x minus e to the x over e to the x. So we are dividing everything by copy of e to the x. Well, e to the x over e to the x is just 1, and we have another copy of 1. Look at this, 7 over e to the x. 7 is a fixed number, while e to the x will grow without any bound. So this is a huge number, while 7 is fixed. In that sense, this limit is 0, and this limit is also 0. So basically, we have negative 1 over positive 1. So the limit is negative 1 over 1 or negative 1. In the second example, our x is getting smaller and smaller. So our x tends to negative infinity. So in this second example, we want to use the behavior of this function e to the 3x. Our x tends to negative infinity. So behavior of this function e to the 3x is quite similar to this function e to the x. As x tends to negative infinity, the function value will be very small, very close to 0. Actually, the limit of e to the 3x as x tends to negative infinity is just 0. So we can use this directly to find the limit. So limit of e to the 3x is just 0. So this function, this expression will be very small as x tends to negative infinity. So basically, we have some fixed number, negative 5 over 2. And that's it, negative 5 over 2. So example 3 is a combination of two functions, e to the 2x and e to the negative 2x. So e to the 2x, the behavior of this function is quite similar, like this. And e to the negative 2x will decrease like this. So basically, as x tends to infinity, those e to the negative 2x, those functions will be very small. They are negligible, actually. So leading terms are 2 e to the 2x and e to the 2x. So you can compare two leading terms to find the limit. You can even guess the limit quickly. Actually, 7 over 4. So if you want, you can divide everything by the leading term to find the limit rigorously. So when you divide everything by e to the 2x, we have 7 e to the 2x over e to the 2x plus 4 e to the negative 2x over e to the 2x, 4 e to the 2x over e to the 2x plus 14 e to the negative 2x over e to the 2x. Now that our x tends to infinity, those guys are negligible, very small. So basically we have 7 over 4. So last example is quite advanced one. So let us use our previous observation about limit of composition functions, and we will try to find those limits. Actually, those functions are compositional functions. When we discuss continuity, we developed some nice property. So when two functions are continuous, we can find limit of this composition by taking limit of inside the function and then apply outer function f. So when two functions are continuous, we can use this property, limit of inside the function and then apply f. When functions are continuous, we can use this property to find limit of some complicate the composition of functions. So eventually, we need to understand this function 3 over x minus 2. If you plot this function, we have a pair of curves like this, and this is 2. Now that our x approaches 2 from the right, so when your x approaches 2 from the right, you can use this graph to tell the behavior of the function. Our function is getting larger and larger. So we can use this observation. So that's one thing we have on one hand, and then we can use this observation. So limit of this guy is, well, we have inside the function. So we take 3 over x minus 2 and apply exponential function. You take limit of inside the function 3 over x minus 2 first. And then you take second function, e to the whatever. So to find this limit, we use this graph. As your x approaches 2 from the right, this function is getting larger and larger. So this limit is infinity, e to the infinity. And e to the unbounded number is again unbounded number, so the limit is infinity. In the second example, I meant x approaches 2 from the left. X approaches 2 from the left. So let us use this x getting closer to 2 from the left. So in this case, our function is very small. So function value is getting smaller and smaller. Okay, so the limit of this is e to the limit of inside the function 3 over x minus 2. Our x tends to 2 from the left. From this graph, we see this limit is negative infinity. And if you look at the exponential function grows in like this, and when your exponent is very small, then the curve is very close to x-axis. So in that sense, this limit is 0. Or you can draw graph of exponential function. When your x tends to negative infinity, your function value is very close to 0. So that's why we have this limit 0. Okay, for the last example, we can use the property of log, property of natural log. So ln A minus ln B. So we can put them together inside a single log. ln A over B, 3x plus 8x squared. So ln A minus ln B is ln A over B. So we are using the property of natural log. And then we want to take limit. Again, this is composition. Then we take limit. Again, this is composition. So inside the function followed by ln, and then we take limit. So as we have nice property here, we can take limit of inside the function and then take ln. So ln of limit 4 plus 3x squared over 3x plus 8x squared. It's quite easy to tell the limit of this guy. Well, leading terms are 3x squared and 8x squared. If you compare them, we have 3 over 8, and that's it. So we use the nice property of limit. So when two functions are continuous, we can use this nice property. So using nice property of continuity, we can find the limit of composition of functions.